See, our target is to prove that acceleration of the two blocks is same. Okay. From this figure, it is I would like to make one thing clear, that capital M is greater than small m. Okay. Everybody can say that as capital M is greater, it moves downwards and it moves upwards. Now, whenever we want to find the acceleration of such systems, we have to take constrained equations. Constraint means constant. What is constant? Length of the string is constant. We have to take that length of the string as a constant. Imagine that here we are using this ideal string whose length is L. So, L length of the string is L, which is equal to constant. And second point is, we have to measure the distances of blocks from a fixed point. So here, what is the fixed point? This roof can be treated as a fixed point. This floor can be treated as a fixed point, or this point level, the point level to the pulley can be treated as a fixed point. So all the distances must measure from a fixed surface. So that's our second point. So here I am going to take this as my reference point, and I would like to measure the distances from this point. Okay. I take this mass m is at a distance x1. I take this mass capital M is at a distance x2. So now this is our x1, this is our x2. And generally we ignore this length, but even if you want to consider this length, take this as xc, means length of the string in the curved part. Length of the string in the curved part. Then length of the string means what? This distance plus this distance, right? Means our x1 plus x2 plus xc is equal to how much? Length of the string. Here, though it is moving like this or like this length remains a constant. Means here this xc is constant and L is constant. If this is moving upwards, means this x1 decreases and x2 increases, right? Or if it is moving like this, x1 increases and x2 decreases. Means these two are variables. These two are constants. Means xc and L are not changing with respect to time. x1 and x2 are changing with respect to time. Now I would like to differentiate the above equation with time t. Then what happens? D by dt of x1 plus d by dt of x2 plus d by dt of xc is equal to d by dt of L. This is a constant. See, if you are perfect with the differentiation, you can understand this part. If you are not perfect with differentiation, go to my previous lectures, mathematical tools for physics. There I have given enough idea about differentiation. Revise that and come back, then you can understand this easily. Now what is this? D by dt of x1 means rate of change of position. X1 means displacement or position is nothing but velocity 1 plus d by dt of x2 means velocity 2 plus 0 is equal to 0. This is a constant. Differentiation of constant is 0. Differentiation of constant is 0. Means v1 plus v2 is equal to how much? 0 I got. Now I would like to differentiate this again with respect to time. Differentiate above equation with respect to time again. So d by dt of v1 plus d by dt of v2 is equal to how much? 0. As v1 is not constant and v2 is not constant, This is rate of change of velocity is nothing but acceleration 1, this rate of change of velocity to acceleration 2 is equal to 0. is equal to 0. Means a1 is equal to how much? a2. But minus means modulus of a1 is equal to modulus of a2. Means the a1 and a2 are having same magnitudes. This minus indicates that both are moving in different directions. If it is moving in the upward direction, it moves in the downward direction, but their magnitudes are same. So hence I proved that the acceleration of blocks which are connected to a single string are constant. Is it clear? What we can conclude? We can conclude that the acceleration of blocks which are connected to a single string remains constant. Okay. In the next lecture, I am going to discuss about some more complicated pulley problems, and then we are going to find the tensions and accelerations in the complicated pulley systems. Okay. See you all.